SwayamPrabha. Digital India. Educated India.
So, welcome to the NPTEL online certification course on structural systems in architecture. So, today we are in module 1 and this is the 4th lecture, and the lecture topic is the structural supports and reactions. So, in that the two concepts will be covered. The first one is the type of structural supports, and the second one is the type of the beam and the respective support reaction. The learning objective for this particular lecture will be that we will try to understand the various structural supports, how it behave and what is the mechanism. Then we will try to interrelate the types of support and the nature of the reaction which is related to the loading, different type of loading. And finally, we will try to establish the procedure to calculate the support reaction. So, how to find out the support reactions also. So, type of structural support, supports are the external system which actually associated with a structural member to ground the loading which is actually applied as external loading. So, particularly suppose I am now sitting in a chair. So, the external loading on the chair is the my load, my total weight of my weight 50 kg or 60 kg. And finally, it is giving the the load is distributed to the ground by 4 legs, and at the particular legs are supported by the ground also. So, at this junction of this legs and the ground, the system is called the support system. Now, there are typically many types of support system, but out of that these 4 types are very common to in our buildings or maybe in various structures. The first one is called pinned or hinge support. The second one is the roller support. Of course, the roller support may be the most general one, then the pinned or the hinged may come. Then there is a support called fixed support, and there are sometimes internal link or the hinges also. The roller supports are something like a support or the member is on a particular roller or a kind of the wheel. So, it is analogous to something like somebody is in a skating ring with a kind of a roller skating ring also. So, it can move, the particular support will allow the member to move in a particular directions. So, you see the second photograph is a roller support which is taken from a bridge, and there are roller support will allow some kind of a thermal expansion and any kind of the dynamic loading. Because of that, it may allow some kind of a movement also. So, if I see a roller support, in the roller support we have to have 3 reactions. Out of the 3 reactions, this roller support cannot move in this direction. As you see, just a minute, as you see, it cannot move in the horizon of the vertical direction, because it is there is no possibilities. So, as it is cannot move in the horizontal direction, it gives me a kind of a the reaction in vertical direction. RV is unknown to me, but this particular support it can move in this direction or it can move in the other directions also because of the roller or for this particular wheel. So, it cannot take any kind of a horizontal direction. So, horizontal direction is always going to be 0. Again, this particular point is a hinge or a pin. So, it can actually move in this way. So, it cannot take any kind of a moment, even if there is a certain amount of smallest amount of moment, it will move. So, it will give a movement in this direction, it can move in this direction. So, there is no question of any moment it can absorb, no question of any horizontal reaction can absorb, only it can absorb or give some kind of the vertical reaction. So, it has out of 3, 1, 2 and 3, 2 degree of freedom. This is the degree of freedom and one unknown reaction, this is the unknown reaction. This is the degree of freedom, this is also a degree of freedom. So, the roller support enjoys 2 degree of freedom and it has one unknown reaction. Now, next is the pinned or the hinge support. Here it is very similar, but it does not have any kind of roller, it is fixed on the base. So, the particular thing, if I say a door hinge is a very common like that, it has a hinge only, it does not have any kind of a roller. So, support is something like our elbow or something like this. So, it has a kind of a hinge only, a kind of a hinge. So, this particular hinge support is very common in trusses and bridges and also sometimes in the building. So, you see this is a kind of a hinge support, this is a kind of hinge, but it does not come under any kind of a roller also. So, in the hinge support, let us see what is the degree of freedom also. So, here you see it cannot take any moment because it is hinge. So, it will again in a certain amount of load it will going to move. So, this is a degree of freedom, but it cannot move like roller or it cannot move like this side or maybe in the upside or downside. So, it has 2 unknown reactions. So, we will see that the degree of freedom is 2 and the number of reactions are degree of freedom is 1 sorry, and the number of unknown reactions are 2 over here. In case of a fixed support, it has everything arrested, something like somebody is holding some stick in a hand or something is very much well grouted in the in a vertical or horizontal plane, those are the fixed support. So, in the fixed support, as it is not under hinge, it cannot move. So, it will have some kind of a moment which I do not know. It cannot allow any vertical or horizontal movement. So, I do not know what is the, so it will impart some kind of vertical and horizontal reaction. So, based on that it has no degree of freedom. So, the unknown is 3. So, the degree of freedom plus unknown are almost about 3, this if you add these 2. So, internal hinge are sometimes also used for any part of the machines particularly, and sometimes it is also used in the trusses. So, if you see a truss, those are the some internal hinge members. So, those are the some kind of widely used in the trusses or so, and link are also something like these are the some kind of a link. So, these are mostly used as in machines or those kind of thing. In building doesn't, it has no such use. But in internal hinge or in this link, the moment is equal to 0, the degree of freedom is equal to 1 over here. So, in that particular link or any hinge, it cannot take any kind of moment. So, degree of freedom equal to 0 and number of unknown equal to your 2, because of both the horizontal and vertical reactions it has to take care. Now, by virtue of that, there is a support system called simply support. In this simply support, we will not going to allow any kind of a vertical movement and also sometimes the horizontal movement may be in one direction, but not in the other direction. So, that the particular plank on particular beam is not going to move from one point to the other. A plank of wood resting on a particular, suppose in a particular 2 concrete block are the perfect example of the simply support. So, there are stone hinges where you see the 2 capital kind of a thing or the pillar kind of a thing is supporting a particular stone on the top, is a very nice example of the simply support systems also. So, again if I come back to this 4 type of support. So, what I have is that in the roller I have vertical reaction, yes, I have to find out that, but there is no horizontal reaction and the moment degree of freedom is equal to 2 and the unknown reactions like 1. So, all the 4 types of the degree of freedom and the, the unknowns are written over there. So, only you see the fixed support has all are yes, that means you have 3 reactions, unknown reactions. Now, type of beam and their support reactions. Now, this is a simply supported beam. So, we can conceptually feel like a plank is hinged over one end and there is a roller support in the other end. So, for the hinge it has two unknowns and 1 degree of freedom, but for the roller it has one unknown. So, what I see is that it has total number of 3 unknowns and we have 3 equation of statics. Last week we have discussed sigma f x equal to 0, sigma f y equal to 0 and sigma m equal to 0. So, I have 3 unknowns and I have 3 equations available, the sigma f x equal to 0, f y and all those. So, I can very easily solve this particular 3 unknowns by virtue of 3 equations. So, that is why this particular beam is a very stable beam and it is determinate beam. Determinate beam means with these 3 equation I can find out the unknowns. Next, suppose it is a cantilever beam. Cantilever beams are those which is having one end fixed and other end is free. So, it has 1, 2 and 3 unknowns and this end is free. So, there is no question of any unknowns. So, the 3 plus 0 is 3 unknowns are there and you have same 3 equations. So, it has also stable and determinate. Propped cantilever. Now, what I did is that in the cantilever I make a kind of a roller in other end. Suppose it is going to bend, so I put some kind of a prop. So, 3 unknowns over here, but here due to the prop this end is not free now, this is having one unknown. So, now the total number of unknown is 3 plus 1 equal to 4 and as it is 3 plus 1 equal to 4, but I still have 3 equations. So, how can I find out? How can I find out the 4 unknowns by virtue of 3 equations? It is not possible. So, it is a stable, definitely it is a stable beam, but it is indeterminate, not determinate, indeterminate. So, I cannot solve this beam very easily, I have to do some other things also. So, we will discuss that in afterwards. This is a hinge support, both ends are hinged. So, there are 2 plus 2, 4 and also it is 3. So, this is also going to be a indeterminate kind of a structure. But if that particular simply supported beam which I have shown just earlier is now under only the downward load, that is only gravity load, then we can say that these 2 reactions are 0, because if there is a downward load there is no question of reaction from the sides. So, in that case this 2 plus 2 will be now remain as 1 plus 1. So, why 1 plus 1? This is unknown and this is going to be unknown. This is already degree of freedom and these 2 are vanish because of the loading are of ground, I mean the horizon vertical one, and number of static equation is now also 2. It is 3 minus 1. Why minus 1? I should not take sigma f x equal to 0 there. This I cannot take because I have no question of the sigma f x equal to 0. So, this is 2 into 2. So, this is also going to be a stable and the determinate equation, determinate kind of a case. So, suppose this is a simply support with this kind of a case. So, whatever we have, and I have a force like a inclined force 42.5 kilonewton in 45 degree. So, as I know you can resolve this force and we have those unknowns. The unknowns are this 2 and this is the third unknown. I have 3 equations, unknowns are 3 and the equations are also 3. So, this structure can be easily solved by 3 equations of the static. Let us solve it. So, this particular 42.2 is now resolved into 45 degrees. So, sine component and the cos component I got. So, this 30 and 30 I got at this particular point. So, I may say that in f x direction this sigma r h a plus this 30, this must be equal to 0. So, that gives me sigma r h a is equal to 30 Newton. Also, I may say that in vertical direction. So, let us remove this thing and let us take some other color, suppose blue color. So, in vertical direction I have this force, I have this force and I have this force, so 30 downward. So, this 3 must be equal to 30. This second equation, I need third equation because I have 3 unknowns. One unknown I already got. The third unknown, third equation is the sigma m moment equal to 0 at this particular point. You can also take b, but let us take at A. So, RV, let us again clear this. So, this reaction VB, this having a perpendicular distance of 4 meter. So, this gives you a kind of a moment like this, must be equal to this 30 into 2 meter, which is this way. So, this plus and this should be equal to make the beam balance. So, I made it equal and I found out what is the RV equal to 15 and the RVA is also 15 because this is 30. So, from that I can find out these two reactions. So, in this case also unknowns are 2 plus 2 4, the number of equations are 3. So, this structure cannot be solved by the 3 equations of the static, because if you see that the same way, if you see that I can find out this RV and RA equal to 15 15 just like other way around, but I cannot find out this and this because this is not 1 now, this is now 2 unknowns are there and I have this 1 equations left with me. So, how to found this 2. So, this is a kind of a statically indeterminate kind of a case. Here in cantilever beam also I have the same representation. So, I know these are the 3 unknowns and number of equations are also 3 and it can be solved by the equation of the static, and again this RH. So, this one must be equal to this one, this force. So, this is 30, fine. RVA must be equal to this force or this force 30, this is fine, and the moment is also fine because this is 30 and the distance between them is equal to 2. So, this is 30. So, 30 into 2 equal to 60. So, these 3 equation can used beautifully and find out these 3 unknown values. These 3 unknown values can be obtained. Propped cantilever, again I have a problem because I have 3 unknowns over here and the 1 unknown over here. I have 3 equations only, so it cannot be solved by the static equations also. So, here if you see these 2 are now going to have 30 degree and this is also the moment equation, and by virtue of only one reactions in the horizontal direction I can find out the sigma A RHA, that is horizontal at A equal to 30, but I have no idea that how can I find out these 3, sorry this 3 can how to found out this 3, it is no, I have no idea because I have only 3 equations and I have 2 unknown, I mean 4 unknowns. So, simply supported beam with the roller and the hinge. So, these are the 2 kind of a thing, it is 2 and equations are 3 unknowns. So, if I have now the 2 hinges with the roller hinges, so I have one unknown, I think this is a wrong this thing, this should be 1, this is a mistake. So, this is 1 unknown and this is another 1 unknown. So, the total number of unknowns are 2 and total number of unknowns are 2 and the total equation is 3. So, this is another case. In this case I have 2 unknowns, but I have 3 equations available for me. So, it will give me a less than the unknowns, it will give me a very unstable kind of a situation. As you all know, if I put a load like this, what will going to happen? This roller will move. So, that gives me the instability condition. So, the structure can have stable or unstable kind of a nature. It can have statically determinate or statically indeterminate in nature. What is statically determinate indeterminate? Again let us discuss. Statically determinate structures are the support reactions can be obtained by the equation of statics, the 3 equation of statics. Statically indeterminate structures are those the support reaction cannot be obtained by equation of statics. So, you need some more equations because as I know, as you see that there are 4 unknowns and there are 3 equations. So, you need one more equations. How to get one more equation? You have to do lot of other things also, some of the compatibility conditions, and I will discuss afterwards, but those structures are statically indeterminate. So, from the moment the unknown reactions are the number of equation point of view, if I see, if the equation is equal to the number of unknowns, suppose 3 and 3, then it is statically determinate. Suppose the support reactions are 4 and number of equations are 3. So, you cannot actually find out the what is the what are the all the reactions. So, it is statically indeterminate. But when the number of equations are 2 unknown equations and equations available is 3, then you have more equations, you do not have that many of unknowns. So, that will give you a unstable case. So, I have some figures for you. So, this is a particular structure which have 3 hinges, one is roller, other 2 are the hinges. So, total number of unknown are 3, because why 3, I have taken only the horizontal vertical forces. So, we have no horizontal comes. So, that is why equation is also 2. So, this is a statically indeterminate 3 and 2. So, next is the static cantilever beam with 2 props, something like that. So, there are 4 unknowns, 2 from here, 1 from here and 1 from here. So, I will write letter 2, 1 and 1. So, and equations is 2, because sigma fx I am not taking, summation sigma fx equal to 0 I am not taking, because I am not considering any inclined force or so. It is also statically indeterminate beam. Now, suppose this is a kind of a figure, I mean the beam where there is internal hinge is there. So, in that internal hinge, this is having 2 unknowns, this is having 1 unknown, 2 plus 1 is 3, and these equations are 2 plus 1. Why 1? 2 are the general equations of sigma f y equal to 0 and sigma m equal to 0, and 1 is a special hinge will give you sigma m at hinge is also equal to 0. So, this is additional equation I am getting here, and that is why this is statically determinate, because 3 is equal to 3. So, the next one is, if it is something like that, this become 2 and this is 0. So, the unknowns are 2 and equations are 2, those 2 and this 1, this is 1. So, again the number of unknowns are less with compared to the number of equations. So, it is an unstable case. As you see, if you put a kind of a load over here, this hinge will going to unstable, it will give you instability, or it will going to rotate kind of a thing. So, now if I have the beams like this, there are loads at different locations, I can find out the R A and R B, the reactions at A and B. So, I know the first equation is that the summation of f y is equal to 0. So, R A plus R B must be equal to 6 plus 4 equal to 10. This is my equation number 1. I cannot take the equation number 2 as sigma f x equal to 0, because there is no inclined load. So, forget about that. Now, I have to take the third equation as sigma moment equal to 0 at A. So, if I take the moment equal to 0 at A, this will not give any kind of a moment, because it passes through that point. The distance between this force and the point is 0. So, I have R B which is having a distance of 4 meters. So, 4 R B must be, so this gives the moment like this, must be equal to moment by of this and moment of this added. So, this 4 is having a distance of 4 meter, 2 meter, plus the 6 is having a distance of 3 meter, 2 plus 1 3. So, this is the another equation 2. Solving this, I can directly find out the R B equal to 6.5 and R A equal to 3.5 can be computed by this first equation. Similarly, this one, if I say that this is how much will be this thing. So, the R A I do not know, also I do not know the M A. The horizontal, there is no question of horizontal direction. So, R A is definitely sigma f y will give me the R A is equal to 12, because R A must be equal to 5 plus 7 and this will be the upward 12, because otherwise this total beam will fall down. And the M A will be find out that, how to find out, because M A, this R A is passing through this point, so no question of the moment generated by the R A, and this is the first moment of M, which is 5 into 3, and the second moment due to the 7 is 7 into 5. So, those if you add, it will be 50 Newton per Newton meter. So, based on this fundamentals, I have concluding this particular lecture on the support and its reaction. So, these are the references. In conclusion, I may say that the different type of support provides different character of the reactions. As I know, the hinge support gives different character, this fixed support gives different character of the reactions also, but the reactions are 3 always. It has a one reaction is upward in direction, one is horizontal direction, and one is moment. Some of the support may have moment 0, some of the support may have the horizontal reaction 0, like that. So, based on this the release of the supports, of the reaction of the supports, we can find out what is the degree of freedom and what are the number of unknowns for the particular support. The structure may fall under statically determinate or statically indeterminate due to the nature of its support system. Yes, because if there are a lot of support system and there are a lot of unknowns are there, and you have only 3 equations of statics. So, based on that, if the equation or number of unknowns are equal to the number of equations, it is determinate. If it is not, if it is more number of unknowns are there, then it is indeterminate. If the number of equations are much higher with respect to the unknown, then it is an unstable kind of a structure. So, my next lecture or the last lecture on this particular module, of course, there is again a small mistake. This is module number 1. So, we will be on the structural loading, and in that we will discuss some of the loading principles of the structure. Now, in the this particular lecture also I have 2 homework for you, 2 homework. The one is that this is a beam is given. Of course, this beam is a statically determinate beam. You can easily find out the reactions at A and reactions at B, both are the upward or the horizontal or vertical reactions. So, there are 2 loads of 10 Newton each at point C and point D, and what you have to do, you have to find the A and B reactions at A and B due to those load. If only load is only at C and there is no load at D, and second case if the both C and D is having load, and in third case if the D is only loaded with that. That is number 1, and number 2, the next homework is that a beam is not a straight beam, it is a kind of a beam and there is a step like thing having 2 meter, 1 meter is 2 horizontal portion and 0.5 meter of the vertical portion is under a 2 equal and opposite kind of a load as 12 Newton, then what should be the reaction at A and B? The A and B, now you see the A will have both the reactions, that means it will have the reactions in the upward and the down, in the horizontal and the vertical. This is having both the reactions, and this is a roller. So, it will not have any reaction in the horizontal direction, it will have the reaction in the vertical direction. So, you have 3 unknowns are over here, and we have 3 equations also, the sigma f x equal to 0, sigma f y equal to 0 and sigma m equal to 0. So, by virtue of the 3 equations, you have to find out the 3 reactions at A and B. That is the second homework for you, and that is all for today.